All right, bear with me on this problem because we're going to use a lot of chalk this time, or a lot of pen. Notice I have two radicals here. So our first step is to isolate one of the radicals to begin with. So let's go ahead and make this a 3x plus 1 equaling an x plus 4 plus 1. I just subtracted x plus the root x plus 4 from both sides. Well, actually, I added it to both sides. Regardless, I have one radical on one side and everything else on the other side. From here, let's raise both sides to the appropriate power. Since it's a square root, I want to raise both sides to a power of 2. Which one do you want to do? I'll do the left side. So the root 3x plus 1 squared just becomes a 3x plus a 1. The right side, x plus 4 plus 1, all that squared, or root x plus 4 plus 1 squared is all that. Do you remember, and I don't know the right place to put this at, do you remember if we have I don't know. This is a plus b squared. And what does that equal? A squared plus 2ab plus b squared. Okay. So I have an a plus b squared. So it's the first term squared plus 2 times the first term times the second term plus the last term squared. A lot of work there. All right, let's clean that up a little bit and see what we have going for us. I have a 3x plus 1 equals an x plus 4 plus a 2 times an x plus 4 plus a 1. Are any radicals left over? There are. So I need to go back and repeat step 1 again, which is to rearrange my terms and isolate a radical. So this is the first example we've seen where we kind of have to do the process a second time. And the reason why we have to do the process a second time is, well, my first step eliminated one radical. I have to do it a second time to eliminate the other radical. Well, not the other radical, but another radical is produced. So let's just clean this up a little bit first and see what's going on. 3x plus 1, x plus a 4. I should have added that 1 to it, so that becomes really a 5 plus a 2, x plus 4. Subtract x from both sides and subtract 5 from both sides. So I have a 2x. Subtract 5 from there. I got a minus 4 equals a 2, x plus a 4. It looks like I can divide both sides by 2 to help kind of clean it up a little bit more. So I have an x minus a 2 equals an x plus, or root x plus 4. Whew. Again, little problems can help us solve big problem. All right, rearrange the terms. Everything's reduced. Isolate the radical. I'm just going to flip it around because I like having it on the right side or on the left side. So that's root x plus 4 equals an x minus 2. Step 2, raise both sides to the appropriate power. Wait a minute, Willie, it just seems like you're doing the same process over again. I am. This was the first time we had to do it twice to eliminate the radicals. X plus 4, root x plus 4 squared is an x plus 4. X minus 2 squared, that becomes an x squared minus a 4x plus a 4. Let's write that a little bit cleaner. X minus 2 times x minus 2 results in x squared minus 4x plus a 4. Let's solve that. It looks like I have an x squared, so let's set that entire term. Let's set something up equal to 0. So let's subtract x and subtract 4 from both sides. So I have 0 equals x squared. Subtract x is minus a 5x. Subtract a 4 from that is a 4, is a 0. How about that? So solve this. I'm going to factor that. So that becomes x. So x minus 5. I just factored an x. For this to be true, either x has to equal 0 or x has to equal negative 5. Now we need to check both solutions to find out if that is true. So let's check the 0 first. Running out of room, like I said, we're going to use some on this one. So my check is 3 times 0 plus 1 minus 0 plus 4 equals a 1. So this is the square root of 1 minus the square root of 4 equals a 1. 1 minus 2 equals a 1. Negative 1 equals 1 is not true. So 0 is not a solution. All right, let's try to see if negative 5 is a solution. Same process. So I have 3 times a negative 5 plus 1 minus negative 5 plus a 4 equals 1. Sorry, folks, it's not a negative 5. You saw that. For this to be true, x has to equal 0 or x equals positive 5. I was going, wait a minute, something wasn't looking right. Thank you for catching that. So that's a positive 5 and that's a positive 5. All right, again, let's solve the right problem, not a problem we introduced a mistake into. Good thing I was going step by step here. All right, so then this becomes the square root of 16, 3 times 5 plus 1, minus the square root of 9 equals a 1. 4 minus 3 equals 1. 1 equals a 1. And that is true. So that tells me then that this plus 5 is a solution to this equation. So this radical equation produced two solutions, 0 and 5. The 0 was extraneous. The 5 was real. So I have one solution, and that's x equaling 5.